Alrighty, welcome to lesson 8 and 9. Today we're building off what we have been doing over the past couple of days. We're practicing writing our equations and manipulating them now into something that is useful for us and something that we can start to work on solving our equations, right? And so today we're focusing on how to solve for a variable, right? Solving for a variable can be helpful in different ways when we have different knowns, different unknowns, and we can start using that as part of our relationship with graphing and solving systems of equations moving forward. So our learning objective today is I can solve for a particular variable like height, time, or length when the equation would be more useful in that form, right? So I can solve for that variable and know when it is more useful in that specific form. And so our vocab word today is solving for a variable. So the first activity should be a bit of a review, completing the table in the relationship between the base length and the area. You also are going to decide whether which equation, and there's going to be more than one, could represent the relationship between B and A. So fill out the table, see the relationship with the equation. This is say from the beginning of our lessons in lesson 2 and 3, and as we start to go into 4. And so explain how these equations represent the relationship between B and A. In the second activity, we talk about a parade cleanup, a post-parade cleanup. So after a parade, a group of volunteers is helping to pick up the trash along a 2-mile stretch of a road. Okay, I see number there. I know that's going to be important, a 2-mile stretch. The group decides to divide, right, another keyword, the length of the road so that each volunteer is responsible for cleaning up in equal length sections. Okay, remember we talked about over the past couple lessons, what are our keywords? I see 2-mile stretch here, I see the word divide, and I see equal length sections. Okay, so find the length of the road section when I have 8 volunteers. Okay, so if I have 8 volunteers and I have 2 miles to work on, I know that I am dividing those 2 miles divided by 8, right? This is my 2 miles. This is my 8 volunteers because we're dividing it evenly, right, in equal length sections between them. And I know that that is going to give me 1/4 of a mile per every volunteer. Oops. Per volunteer. Right. Every volunteer has to do a 1/4 of a mile, right? And you can see that if you want to create a actual line too, right? Here's our 0 mile, here's our 2 mile. If I divide this up in 8 equal sections, how much does each person get, right? We have 1 section, 2 section, 3 section, 4 section, 5, 6, 7, and 8. I'll make it a little bit bigger here, right? So if we have our 8 sections, for every volunteer, right? 1, 2, 3, 4, 5, 6, 7, 8. How much is each of these sections? Right, and you could just add them up too. Right, I know that if this is a fourth, so for checking my answer, right? A fourth, this gives me 1 mile. And I have another fourth, another fourth, another fourth, and another fourth. This also gives me 1 mile. In total, I have 2 miles. Right, so you can draw a picture if you are struggling to see what's going on. And so, okay, so I know that with 8 volunteers, I have a 1/4 of a mile. And if I wanted 10 volunteers, right, or I can even leave this as 2 miles over 8, if that's easier for you to see. If I have 10 volunteers, I have 2 miles over 10, right? Because we have 10 volunteers now, dividing that section up into 10 parts. And so the question is now, what would happen if I don't know if I have any number of volunteers, right? If I have a general number of volunteers. And so I can generalize this by saying, all right, I still have my 2 miles and I'm dividing, right? Think about our keyword by the total number of volunteers. In this case, it is n. Right? We don't know our total number of volunteers. And so once you submit, explain where that L and that N came from. And so that's why sometimes having a sometimes solving for a variable, right? Isolating the variable that we're interested in can be an efficient way for solving problems, right? You can very easily be like, okay, the length times the number of volunteers should equal 2, which is absolutely true. And that's one way of writing your equation. And so you want to see that why is this more helpful? And I think it'll be more clear for you as you get on to the second page, where you want to now, given the mile, find the number of volunteers, or how can we write it where n, which is the number of volunteers, is given when we know the number of miles. So think about what we did in the last problem. Draw a diagram, draw a picture if you need to. And so for the last activity, right, you're given a cargo shipping, which is an automobile manufacturer is preparing a shipment of cars and trucks on a cargo ship that carries 21,600 total tons. Each car weighs 3.6 tons each, and the trucks weigh 7.5 tons each. Write an equation that represents the weight constraint of shipment. Let C be the number of cars and T be the number of trucks, right? This should be a review from before. What is my total number? My total weight constraint is 21,600. And I know that that must equal the total weight in cars, right? 3.6 per car plus 7.5 T, 7.5 pounds per car, tons per car, per trucks, sorry. So we have our we have our tons for each car, which is 3.6, plus 7.5, which is each ton for the truck, right? For each truck. And so this should be a review from the previous lessons, but something you just want to keep in mind as we go forward. Because then once we start getting into it, we notice that for one of the shipments, if the truck is loaded first and the cars are loaded afterwards, find the number of cars that can be shipped if the cargo already has a number of trucks. And that's what I was talking about before. It can sometimes knowing and isolating one variable is a lot easier than working with our original equation, right? We had 21,600 is equal to 7.5 T plus 3.6 C. This is our original equation. And now we know the number of trucks. And so how can we use that to find our number of cars? Let's say I know the number of trucks is 480, right? 7.5 times 480 plus 3.6 C, right? Replacing your variable. Think about what you were talking about before. And so for 480 times 7.5 gives you 3,600 plus 3.6 C equals 21,600. I'm going to run out of space, so I need to write over, let me come over here. So now I subtract 3,600 from both sides because I want to isolate my variable. Remember what we talked about, the goal now is to figure out what C is. So how can we solve for that variable? So 21,600 subtracted by 3,600 gives me 18,000, 18,000, which is equal to 3.6 C. And to solve for C, opposite operation of multiplication is division. And so my operation here is division. This simplifies down to 1, and you get 3.6. You get 5,000 cars total. If I have 680 trucks. And so that is very important when you are thinking through your process when I don't know my number of trucks. All right, so if I know my number of trucks, it's very easy to start to solve things. And think about it when you are doing your second one too with the 1,500 trucks. But what happens if I don't know my number of trucks? Think about each of the processes you did. Right? Here I subtracted, here I divided. What if I have T trucks? How can I solve for C with just T trucks? So that's what you want to think about. And think about what you did in the previous problem too. And so you can, even when you're starting off your original equation, right, you're going to start off with this part, right? And instead of replacing a variable, you're not going to have a variable to replace. Come on. Right, you'll start off with this one. And how can you solve for t? I mean, how can you solve for c here, right? We want to end up with having c. How can I solve for c here? What do I do? I can leave t alone, but I need to isolate my variable. So think about the steps you would take to isolate your variable. Think about the moves that I made. I subtracted, I divided. So one step at a time as you're going forward. And so we'll be reviewing that in class as well. And so same thing with the other side, right? If I know the number of trucks and if I know the number of cars and I want to find the number of trucks, right, that will be helpful in doing this. And you'll notice a pattern going forward. And remember, when you have equations, you can always check your answer, right? If I get t equals something, substitute a value in from this slide back here. Right, you have, if you, for 480 trucks, you know that the answer is 5,000. And so you can use those two numbers to help you check your answer. So always going back to check your answer. And we end up with our lesson summary here, right, going over the relationship between quantities. Here it gives you an angles. Further along in lesson 9, it talks about the relationship between an elevator and pounds. Take a look at what the walkthrough is here, right? What are you doing to the original equation to isolate your variable? Think about opposite operations. If I'm multiplying by something, what is the opposite of that? If I'm adding by something, what is the opposite of that? And so we'll be using this as we move forward in lesson 10 and beyond. And so I will see you there.